Hi everyone. Hopefully the quiz went well for you on Module 21, and if you guys haven't taken it yet, remember it's on HMH. So we're going to start Module 22, which is about conditional probability and independence of events. And the first section, 22.1, focuses on conditional probability. So we're just going to calculate conditional probabilities today. And if it will go to the next slide. Okay, so conditional probability is the probability that event A occurs given that event B has already occurred. Okay, so you're going to start off with some information about the situation. Something will already have happened. So the way we express conditional probability is with this line. And the way that we read this is the probability of event A happening given event B has already occurred, or shorthand, probability of A given B. There's a formula for this. Probability of A given B is equal to the probability of A and B divided by the probability of event B. So you're always going to divide by the given event. And then if we look at it vice versa, probability of event B occurring given event A has already occurred is equal to the probability of A and B divided by the probability of A. Again, you guys are always going to divide by that given probability. So let's do an example. We have this little table of data here. 100 migraine headache sufferers participated in a study of new medicine. Some were given the new medicine and others were not. After 1 week, participants were asked if they had experienced a headache during the week. So we just have it classified by headache or no headache versus whether they took the medicine or they didn't take the medicine. So event A is going to be that they did not get a headache. So no headache, that's event A. And then B is that they took medicine. So here's event B. We're going to calculate the probability of A given B. So event A given event B has already occurred. So in context, this is the probability that they did not get a headache given they took medicine. So using the formula, that's the probability of A and B divided by the probability of B. Okay, so A and B would that be that they didn't get a headache and they took medicine. So they did not get a headache and they took medicine. That's 54 people out of 100 people total. And on the bottom, we have the probability of B, which again is that they just took medicine. So that's 65 people out of 100 people took medicine. So what happens with this fraction over a fraction is the 100s cancel and we're just left with 54 out of 65. Let's do another example. So this table shows the results of a customer satisfaction survey and 100 randomly selected shoppers at a mall. They were asked if they would shop at an earlier time if the mall opened earlier. So they either answered yes or no to the question, and then they were classified by age, and then we have percents in the table rather than counts. So what's the probability that a person aged 10 to 20 answered yes? So here the given information is the fact that they're 10 to 20. So this is the probability that they answered yes, given that they're aged between 10 and 20. So again, using that formula, we have probability of yes and age 10 to 20 divided by the probability that they are aged 10 to 20. So yes and 10 to 20 would be that 13% right there. And then the probability that someone is aged 10 to 20 is a total of 38%. So in our calculators, we would do 0.13 divided by 0.38, and we get 0.342. Okay. All right, next one's similar. So what's the probability that a person who answered no is aged 21 to 45? So this time we know that they answered no. That's the given information. We're finding the probability that they're 21 to 45 given they answered no. Same formula. On top we'll do 21 to 45 and they answered no. And on bottom we will do the probability that they answered no. So 21 to 45 and no would be this 10% here. So we'll put that 10% on top. On bottom, just the probability that they answered no would be 0.53. So again, we would divide those two things in our calculator and we get 0.189. So 18.9% chance that someone is aged 21 to 45 given they answered no. All right, so the last example, we're just going to be working with a standard deck of playing cards. For the first one, we're going to find the probability that a red card randomly drawn from the deck is a jack. So here what we know about the situation is the card is red. So we're finding the probability that the card is a jack given the card is red. And again, we're going to use that same formula. Probability of jack and red divided by the probability of red. So how many red jacks are there? There's 2 red jacks, right? Both a jack and a red. That's 2 out of 52 cards. And then red cards, that's 26 out of 52 since half the deck is red. So the 52s cancel. We're left with 2 out of 26 or 1/13. And now we're going to do the opposite of these. So we're going to find the probability that a jack randomly drawn from the deck is a red card. And this one's a little intuitive. You can kind of figure it out just using logic. But this time we know the card's a jack. So we're finding the probability that the card is red given it's a jack. So same thing on top, probability of red and jack. But this time we're going to divide by the probability that we get a jack since that's the given event. So red and jack is again 2 out of 52. There's only 2 cards that are both red and a jack. And then probability of a jack, that's 4 cards out of 52 cards since there's 4 jacks in a deck. And that simplifies to be 2 out of 4, which is 1/2. Again, this kind of makes sense. Probability of a jack being red, you know there's 4 jacks, you know 2 are red. So again, that's why we're getting 1/2. So that's conditional probability for you. Let me know if you guys have any questions.